name's Charles Edge. I'm an engineer and partner at 318, a security and network consulting company in Santa Monica. We do a lot of really high-speed networking, 10 gig stuff, 12 gig stuff. We're getting into 20 gig stuff. So different SAN solutions has been a big focus of ours for the last couple of years. I specifically wrote a book a couple of years ago on Apple's Tiger server. I'm in the process of updating it for Leopard. And I'll be doing one on Xsan as well shortly. So that's it about me. Fiber channel. What is fiber channel? Does anyone, who knows what fiber channel is? Let's just throw it out that way. All right, fiber channel is basically like SCSI, except for multiple people can tap into it at once. So, and it also expands the range from having 7 or 8 possible IDs to having 64. So, you can use GBIC or SFP adapters, so copper or glass. And the switches allow equal opportunity as a possibility for all the nodes on the network, which means that each node has pure gigabit as opposed to 600 or 700 megabits worth of speed to the devices. Or if you go 10 gig, each node has 10 gigabits. In order to not clutter the streams with the act of finding files and things of that nature, Apple has, in their SAN, implemented what they call a metadata, an out-of-band metadata network. And that out-of-band metadata network is used to process things like file permissions, file locations, anything that in an Apple environment would typically be interfering with the streams. So as far as data usage goes, a SAN provides for virtualized data, which means that you can have 8 RAIDs as one volume. You can have 10 different people streaming data off of that one volume. So the clients for Xsan are typically G5 nodes. In my case, my client is MacBook. And what I've done for this presentation is I've actually hacked my USB interface to pretend that it's fiber channel for today. So my machine is actually acting as a SAN, and my LUN or my storage pool is this handy dandy USB jump drive. So, all right, and then I guess as far as size goes, you can get your Xsan up to a petabyte. I'm not sure exactly how Apple intends to get it up to a petabyte, since you can only have 64 WWNMs on the SAN fabric at any given time, which means that if they have 7 terabyte X RAIDs and each X RAID access 2 LUNs or 2 WWNMs, then you can never actually make it up to a petabyte. But the theoretical limit is a petabyte. So let's see. As far as the way that Xsan works, that's a little different from a lot of other SANs. You basically add multiple LUNs into a storage pool, and then you tell the LUNs as you're adding them into the storage pool how many, whether or not to add data to the storage pool in a weighted fashion or to do it in round robin. So if you have like one RAID that's 3 terabytes and another RAID that's 7 terabytes, you can tell it to proportionally assign data. And then multiple storage pools become a volume, and you can do the same thing with the storage pools. You can also configure the stripe breadth, so how many K are written to each stripe or to each LUN before moving on to the next one. So let's see. I think I got a little ahead of myself. The metadata concept is important because as it's moving data, because it breaks it into chunks and puts it on each LUN, you never know exactly where the data is going to be on your given RAIDs. So while it's writing data, it has to have the access to the metadata, and the metadata is stored on the first LUN. And that's kind of where we're going to start our attack on this. I was basically contracted by the consortium of film engineers to, or the film companies, I guess, to look at this because they're kind of concerned about people stealing their bad movies these days. So basically, in order to provide the equal opportunity access or the high-speed access that the SAN is trying to provide. Because for HD streams, you have 1.6 gigabits per second for 1080i, and then 3.4 gigabits per second for 1080p, which means each client on your SAN has to have, basically, for 1080p, 4 aggregated to be able to stream one stream of 1080p, which is, you know, the high def thing is definitely making us rethink the way that we build networks in Hollywood. But but basically, in order to provide the equal opportunity access, then each client has to be able to read and write to the metadata one, which is kind of an inherent flaw, because if each client can read and write data to the metadata one, and then each client can fill up the metadata one, that will cause essentially a DOS of the SAN. You can also cause a full corruption of the volume by writing bad data to the metadata line. So, does that make sense? Everybody's tired this morning, aren't they? I knew I should have brought a couple books and given away free swag. Damn it. All right. I was going to, I just forgot. Sorry about that. So if the metadata becomes full, then the SAN won't function. And paths for new files can't be written. Paths for existing files, if you inject bad data into the line, can't be found. So essentially you orphan out your files. They're still there, and you can actually rebuild your metadata, but I've never met anyone who can figure out how to do that, including the engineers at Apple. So, does anyone here work for Apple, by the way? Okay. I've been talking about hacking Apple products for like 3 years, and there's never been anyone from Apple in one of my presentations. I thought that was kind of funny. All right, so if the metadata line is destroyed, then obviously the SAN won't function anymore. So each line is shown as a disk in the dev directory. If you don't know which disk each line is, you can always look in Apple System Profiler or in Disk Utility. When a line is listed in Disk Utility as an Apple Xsan component, it doesn't actually list the dev device, but in Apple System Profiler, you can actually look and see what the disk name is. So as far as finding your metadata line, that's pretty easy. Essentially, what I've done is usually I'll just mount the first disk and I'll start writing arbitrary data to it, and I'll loop my write until the disk is full, and then the SAN will no longer mount. Regrettably, I did this on my own machine last night, so I can't show you the SAN not mounting anymore. But I promise it works, and it's really, really easy. So once the SAN has crashed, the configuration files will be out of sync, and the volume won't start anymore. So then you have to restore. And in about 80% of the SAN situations that I've looked at for the film industry specifically, or for Apple-based SANs, they don't back up. They just can't fathom the concept of trying to back up 25 terabytes, so they don't bother doing it, which is kind of a weird thing. But so the challenges that I've run into in doing this, or talking about this with people from Apple, is that they don't know what volume is the metadata. I already showed how to figure that out, so I won't go over that again. On it. All right, everybody hear me still? Okay. So I think I was talking really fast while I was doing that earlier. Are there any questions about anything I've covered so far? All right, I'm really hot, so I promised my business partner I would wear a jacket, which was stupid. Okay, so essentially, this is what the cat contents of a regular disk, or the contents of a regular disk, are going to look like. In the case of an Xsan disk, the contents actually start with the LUN name. So if you're not sure if you've got the right LUN when you're working on something like this, you can always just look at it, and it'll tell you the LUN name. And then injected in here is also the volume that that LUN's a member of. So volumes can be members of multiple. LUNs can be members of multiple storage groups in each volume. So, and then this is just some arbitrary garbage data I wrote to it. So, and that's just cat in the contents of disk one. I could also try to write a tar file into there, or extract the tar file into the disk, and that would instantly wipe it out. One point of note is if you rm disk one, and you just do rm or sudo rm disk one, then all you'll do is you'll end up unmounting the SAN for all the users on the fabric. So that's kind of a fun thing to do if you want to go home early. Looks like I had all these terminal windows up so that I could just show them instead of having to hunt for the commands. But all right, so different ways to protect against these types of things. Obviously, controlling the physical access to the fiber channel network or fiber channel switch is a really good idea. Anyone who jacks into the fiber channel switch is going to get /dev/disk, whatever disk that those LUNs are, whether they've actually authenticated into the SAN or not, which is to me kind of a big thing. Obviously, you're not going to be able to walk in with a laptop and hack into someone's SAN, because you're going to need a fiber channel card, which most laptops don't have. But still, you can do that. In every case that I've ever walked into an Xsan that was deployed, the default password is on the fiber channel switch's Ethernet interface. So anyone can actually just open up a web browser, go to the default IP of that fiber channel switch, and change its settings or do whatever. Using policies to remove the access of terminal emulation on client systems, especially Macs, using Open Directory, you can actually disable the ability for users to, really? 20 minutes. Thanks. Using Open Directory, you can actually just disable the access for terminal app. Users can then reboot to a CD, reset the root password, change the UID of the root to the directory administrator UID, and privilege escalate themselves. So any privileges that you assign to files on the SAN are pretty much no good. You can use larger LUNs to house metadata. That way that any loops that are occurring to write data to the metadata volume will take longer to run. Obviously, maintaining good backups of your SAN data itself is critical. Some people claim that they can maintain good backups of the metadata. It's not possible. You can't really snapshot a moving target unless you're not writing data to the SAN at the time. There's a lot of SAN products offer snapshot backups. Xsan doesn't. So, although it may be coming next week at WWDC. Maintaining backups of your config files is pretty important, because if the LUNs become out of sync, you can always just go into your config files and change the bit size of the data sets. Password protect the machines that have access to the SAN and the open firmware. That's really easy to get around. You just reset the RAM and that password is gone. So a lot of people use LUN masking. If you're running multiple volumes, then LUN masking works pretty well in Xsan. If you're not running multiple volumes, it doesn't, unless you're using affinities. And affinities are a way in Xsan of saying that only X users have access to X data. If you're going to deploy affinities, you should also do that in conjunction with LUN masking, which is performed at the switch level. The thing about LUN masking is if you switch your ports on the SAN, then you get access to things you maybe aren't supposed to. So if any node on the SAN is compromised, typically all the nodes are compromised because the root password for each machine is known by the metadata controllers. So if you're able to root one box, then you've rooted the whole thing. And LUN masking isn't good enough because, I already said that. About 80% of the fiber channel switches I said have the default administrative password. The other 20% are the ones I set up for Xsans. So at this point, I think I have set up about 20% of them. In my case, I guess I am using, I mentioned this earlier, but I'm using my USB flash drive as my main LUN. And I'm running Xsan 1.3. One really kind of cool thing about doing that is at home I've got two 1 gig USB drives, and I've aggregated them so that I get 2 streams of USB 2. So it's actually a lot faster than a regular USB jump drive. It's about twice as fast, and it's 2 gigs of space. So that's kind of cool. How much more time do I have? 3 minutes. Okay, quick questions. Anybody? No love. You're all so tired. I knew I should have brought swag. God, I suck. My wife told me, no, don't. I think she hid the books from me so I wouldn't bring them. How about the promise of future swag? Any questions? A good question? Thank you. All right, well, I'm all done then.